Hello students, welcome back. Let's resume L'Hopital's rules. We went through elementary L'Hopital's rule problem like these, and a little bit higher level, changing product to fraction. Now we have to consider something like these, when both the power and base are functions of x, or a of x to the b of x power type. How do we handle this kind of limit computation? Here's an example: x to the x squared power, or x to the 1 over x power, things like those. Typically there are two methods. One is to take log and calculate the limit of this log, and then in the end take the exponential to get it back. This is what I'm talking about. Log of x to the x squared, let's suppose we have something like this, then you can apply the log rule. This power comes out as coefficient, and we have something like this. So by taking the log, this a of x times b of x power became a product u times v form. We're almost there. If you change it into a fraction, then we're going to be ready to apply L'Hopital's rule. And here we go. As usual, keep logarithm upstairs and then push this power function down below, and we are ready. This is a fraction, and this is infinity over infinity form as x is going to 0 plus. So we are in good setting for L'Hopital's rule. Take the derivative, take the limit, and then in the end, don't forget to take the exponential back. That's one way. Another way is to do this. Let me write down the general formula here. A to the b power is equal to exponential of b times log of a. If you use this formula, you can change this form, something like this, into this. This one equals to e to the x squared times log of x. This is b and log of a. Now change this product upstairs into fraction. Exponential of log of x over x to the negative second power. We have a fraction here now, so we can apply L'Hopital's rule. In this method, if you find the answer, that's it. You don't have to take an exponential back or something. So I like this method a little bit better. And there's a secondary reason, as a matter of fact. It is a little bit theoretical. How do you define this kind of expression to begin with? What do you mean by x to the something power, where both the base and then power are functions? Well, it is defined like this using natural exponential functions. So that is the second reason I prefer the second form. But if you disagree and if you prefer to use a textbook author's method, that's okay. Now let's go. Solution 1 is our textbook author's method. Take the log and then get this power out as a coefficient. If we do that, then we have a product form. Now push this x squared down below and get a fraction form. We are ready for L'Hopital's rule. Take the derivative, simplify, and then no more denominator, so plug in x equal to 0. Voila, we have the limit. Okay, but that's not the end of the story. Because we took the log to calculate all this, we have to take the exponential back. We have e to the 0 power, which is 1. Please do not forget the last step. I remember because I once forgot the last step and then lost some point when I was a student. I still remember that. Second is the method I personally prefer. How do you handle it? X to x squared part. Okay, this is e to the x squared power times log of x, this one. And then we have limit of this practice, limit of this product, excuse me, sorry about mispronunciation. And then you can change this into limit of fraction. Okay, there you go. And then you can apply L'Hopital's rule, do everything, then you're gonna get e to the 0 power. Because this whole thing over there, if you use L'Hopital's rule and everything, you're gonna get 0. So in the end, we get e to the 0 power, which is 1. I skipped a little bit of step here because I did it already in the previous problem here, this part. Otherwise, pretty much the same. Which solution do you prefer? I personally prefer the latter, but if you prefer the first, please go ahead and use it. In my experience, majority of the students prefer the textbook's method, this one, over that one, even though I taught both. Let's do just one more time. This time, let's see. What should I do? Okay, the last one. X to the 1 over 1 minus x power. Okay. Base is a function, and then the power is also a function. Okay, how do we handle it? Solution number 1, take the log, and then take this fraction 1 over 1 minus x, excuse me, this one out using the log rule. So what do you get? 1 over 1 minus x times log of x, so we have a fraction. Next, applying L'Hopital's rule, we get something simple. We had 0 over 0 type limit. Alright, so we can use L'Hopital's rule, by the way. Log of 1 is 0, 1 minus 1 is 0. Okay, L'Hopital's rule works. This is negative 1, so upon taking exponential again, we get e to the negative first power, or 1 over e. This is solution 2. Taking exponential of b times log of a. Can you read it? b times log of a. Then what do you get? Exponential of this fraction. You can apply L'Hopital's rule. And then what do you get? You just get e to the negative first power and you stop there. Which method do you prefer? I like the second method a little bit more, but majority of my students used to prefer the first method. I've been teaching this calculus one for a number of years, and I have some accumulated data, and most of my students usually prefer solution number 1. Well, there are a couple more, but I'm going to leave those to you. They're all difficult, and in the next video we're going to go over to section 3.